There's a sound coming from the space between the stars. It is faint, almost impossibly faint, a thin, steady tone that never stops, and for most of human history, nobody knew it was there. The region it comes from was supposed to be the quietest place in existence, a near-perfect emptiness, stretching between the sun and its neighbors, a vacuum so complete that it should produce nothing at all. No sound, no signal, no hum, just silence and cold and nothing. And yet the tone is real. It has been recorded, measured, checked, and confirmed, and it is coming from a place our best science insisted should be silent. The instrument that heard it is a machine built almost 50 years ago, running on a sliver of power, drifting farther from Earth than any object humanity has ever made. It was never designed to find this. It was never supposed to still be alive. And the discovery it made, once the scientists finished checking their work and NASA confirmed the result, forced a quiet but genuine admission from some of the most respected physicists studying the outer reaches of our solar system. The empty space between the stars is not what they thought it was. It is not silent, and they are not entirely sure why. The machine is Voyager 1, and to understand why a faint hum from the dark could unsettle the people who study the cosmos for a living, you have to understand where that hum is coming from, and how the oldest working spacecraft in deep space came to be the only thing in existence capable of hearing it. Voyager. One left Earth in the late summer of 1977, one of a pair of probes launched to take advantage of a rare alignment of the outer planets that would not come again for well over a century. The mission everyone was told about was almost modest. Fly past Jupiter, fly past Saturn, gather what science could be gathered from those two giant worlds, and then let the spacecraft drift, tee on into the dark, its real work finished. The engineers who built it hoped for a handful of good years. They did not promise decades. They did not imagine that the machine would outlast their careers, that some of them would retire and pass away while it kept flying, that nearly half a century later it would still be sending signals home from a place no human being will reach in any of our lifetimes. But that is exactly what happened. And the reason it happened is tied to a single decision made at Saturn. At Jupiter in 1979, Voyager 1 sent back the first close portraits of that enormous banded world and discovered volcanoes erupting on the moon Io, the first time anyone had ever seen active eruptions on another world. At Saturn, the following year, it revealed the rings in extraordinary detail, thousands of fine divisions and braided strands no one had known were there. And then, to get the best possible look at Saturn's giant moon Titan, mission controllers steered the spacecraft onto a path that flung it up and out of the flat plane where all the planets orbit. That choice ended its tour of the planets. It would visit another world. But it aimed Voyager 1 at something no spacecraft had ever reached, the true edge of the solar system, and set it climbing outward on a trajectory that would eventually carry it across the greatest boundary our sun possesses. To understand that boundary, you have to picture what the sun actually does. Our star does not simply sit and shine. It blows constantly in every direction, a steady wind of charged particles streaming outward at enormous speed. The solar wind carves out a vast bubble around the entire solar system, an invisible domain where the sun's influence dominates, where its magnetic field fills space and its particles set the rules. Everything you have ever known, every planet, every mission, every human being who has ever lived, has existed inside that bubble. But the bubble is not infinite. Far out, well beyond the orbit of the outermost planet, the pressure of the sun's wind blowing out, it finally meets the pressure of the thin gas that drifts between the stars, and at that meeting point, there's a kind of shore, an outer edge to the sun's entire kingdom. Scientists call it the helopause. Beyond it lies true interstellar space, the region governed not by our star but by the galaxy itself. For 35 years, Voyager 1 flew toward that shore, and in August of 2012, it crossed it. The instruments recorded a sudden and dramatic change. The particles streaming out from the sun, which the spacecraft had been swimming through for its entire journey, dropped away almost to nothing, while the count of high-energy particles arriving from the wider galaxy jumped sharply upward. Voyager 1 had passed out of the sun's bubble and into the space between the stars. For the first time in the history of our species, a machine built by human hands was directly inside the interstellar medium, sampling it from within. No probe had ever done it before. None has done it since, except its own twin. Every direct measurement we possess of what interstellar space is actually like, we owe to this single aging machine, out there in the dark, taking readings and sending them home. It's worth understanding how carefully that crossing had to be confirmed, because the word confirmed sits right there in the claim, and it was not lightly earned. NASA did not announce the crossing the moment it happened. The team argued about it for a full year, because the evidence was ambiguous and the stakes were high. Declaring that a human machine had left the solar system, for the first time, was not something anyone wanted to get wrong. The decisive proof came almost by accident. An eruption on the Sun, launched months earlier, finally caught up with Voyager 1 in the spring of 2013 and set the plasma around it ringing. When the team measured the pitch of that ringing, the density it revealed was unmistakably that of interstellar space, far higher than anything inside the Sun's bubble. That single measurement, arriving nearly a year late, was what finally convinced them the spacecraft had truly crossed over the previous summer. They had not watched it happen. They heard its echo months afterward and reasoned backward to the moment it occurred. That is what confirmation looks like at the edge of the solar system. Slow, indirect, argued over, and only accepted once the evidence left no other choice. But here the story takes its first strange turn, and it is a turn that had nothing to do with the hum, and everything to do with how little we truly understood the place Voyager was entering. As the spacecraft approached and crossed the heliopause, scientists were watching one measurement with particular attention, the direction of the magnetic field. Inside the Sun's bubble, the magnetic field has a particular orientation, shaped by the Sun. Outside, in interstellar space, the feel. D belongs to the galaxy, and the models predicted it should point in a noticeably different direction. So as Voyager 1 crossed from one realm into the other, researchers fully expected to see the magnetic field, SOS, wing around to rotate into a new orientation as the spacecraft left the Sun's influence and entered the galaxies. It was one of the clearest predictions they had, and it did not happen. When Voyager 1 crossed the boundary, the direction of the magnetic field barely changed at all. It stayed, stubbornly high, pointing in nearly the same direction it had inside the bubble. The interstellar magnetic field, against every expectation, appeared to be lined up almost perfectly with the Sun's own, as if the galaxy just beyond our doorstep happened to share the orientation of our star, a coincidence so unlikely that scientists still argue about what it means. It was the first sign that the space beyond, the heliopause, was going to keep breaking the rules, that our confident picture of the interstellar medium was built on far shakier ground than anyone had admitted. And then came the sound. To understand how Voyager 1 could hear anything at all, you have to know about a piece of bad luck that happened decades earlier, because it turns the discovery of the hum into something close to a detective story. Voyager 1 carried an instrument, designed to measure plasma directly, to count the charged particles around it and gauge their density. That instrument failed in 1980, early in the mission, long before the EE spacecraft ever reached interstellar space. So when Voyager 1 finally crossed into the region scientists most wanted to measure, it had lost the very tool built to measure it. It could not simply read the density of interstellar space off a dial. The most important measurement of the entire journey was, in the most direct sense, impossible for the spacecraft to make. So the scientists found another way, and it depended on a different instrument, one that does not count particles, but listens for vibrations. It is called the plasma wave subsystem, and it works something like a microphone for the electrically charged gas that fills space. Plasma, that charged gas, can carry waves, and the pitch of those waves depends directly on how densely the plasma is packed. Pack it tighter and the natural tone rises, thin it out and the tone drops. If you can hear that tone and measure its pitch, you can work backward to the density of the plasma around you without ever counting a single particle directly. It was an indirect method, a clever workaround for a broken instrument, and it turned out to be the key that unlocked everything. At first, the spacecraft only heard the plasma when something loud disturbed it. Every so often, the Sun would hurl out an enormous eruption, a violent burst of energy that traveled outward for months, crossed the heliopause, and slammed into the interstellar medium beyond, setting the plasma ringing like a struck bell. When that happened, Voyager 1 would catch the tone, and the scientists would read the density from its pitch. Researchers came to call these arrivals tsunamis, waves of pressure rolling out from the Sun and crashing over the spacecraft long after leaving home, taking the better part of a year to make the crossing. Each one, when it hit, made the plasma sing, and the spacecraft dutifully recorded the note. These events were precious, but they were rare, scattered loud notes with long stretches of silence between them. It was like trying to understand the weather across an entire continent by waiting for the occasional distant clap of thunder. You could learn something from each strike, but between them you were blind. Then, years into the interstellar journey, a researcher combing carefully through the data noticed something that should not have been there. Underneath the rare, loud events, buried in the quiet stretches everyone had assumed were empty, there was a sound that never stopped, a faint, steady, narrow tone, present continuously, running through the data month after month, year after year. It was extraordinarily weak, so weak it had been overlooked entirely. But once its signature was recognized, it became unmistakable. A persistent hum humming quietly in the supposedly silent dark. The interstellar medium, the region that was supposed to be the very definition of empty, was singing on a single low note without pause. And that note carried information, because its pitch revealed the density of the plasma prod. Using it, For the first time, scientists had a continuous reading of the density of the space between the stars, not scattered thunderclaps, but a steady tone they could follow without interruption. When this was checked and rechecked and finally confirmed, the discovery made headlines, and it deserved them because a hum from empty space is a genuinely startling thing. But the deeper significance was not the sound itself. It was what the sound revealed, and what it revealed was the impossible part. Before Voyager arrived, our entire picture of the interstellar medium came from a distance, inferred from starlight, built from theory. In that picture, the space between the stars was supposed to be an almost perfect empty. In S, a near vacuum, thin and smooth and calm, with perhaps a single atom scattered through a volume of space, sparser than the best vacuum any laboratory on Earth can produce. That was the expectation. A silent, empty ocean of nothing but the continuum. House tone Voyager was hearing told a different story. The plasma out there was denser than the models predicted, and not by a small margin. The near vacuum was less empty than it was supposed to be. That alone was enough to send physicists back to their equations. But the tone did not stay put. As Voyager 1 kept moving outward, deeper into interstellar space, the pitch of the hum did not settle into a single steady note. It climbed. The density of the plasma, according to the continuous reading, was increasing the farther the spacecraft traveled from Sun's protective bubble. Move away from the heliopause into what should be ever emptier space, and instead of thinning out, the medium grew thicker. This ran against deep intuition about how the region ought to behave. Why should the space between the stars become denser as you leave the influence of our own star behind? Nobody had a clean, agreed-upon answer. There were ideas, competing explanations, arguments about the sun's bubble compressing the plasma just outside its edge, about magnetic fields and pressure and structures in our local corner of the galaxy that our models had been too crude to include. But the honest position, stated plainly by the researchers themselves, was that the data had gotten ahead of the theory. A nearly 50-year-old spacecraft listening to a hum it was never designed to hear, using a workaround for an instrument that had failed to Sentio decades earlier, had caught our understanding of interstellar space falling short of reality. The models would have to change. The measurement was not going to bend to fit them. There was another discovery folded into the crossing, one that touches us more directly than a distant hum, and it concerns radiation. The galaxy is filled with cosmic rays, high-energy particles flung out by exploding stars and other violent events, racing through space at nearly the speed of light. These particles are dangerous, capable of damaging living cells and the delicate electronics of spacecraft. And one of the things the sun's great bubble does, it turns out, is shield everything inside it. As Voyager 1 crossed the heliopause, its detectors recorded a sharp jump in the number of galactic cosmic rays striking it. A clear sign that outside the bubble, the bombardment is far more intense. Inside, where all of us live, the sun's outflowing wind and magnetic field push a large fraction of these particles away, holding back a storm of radiation we never knew was being held back for us. Voyager 1 flew out past that protective wall and measured, for the first time from the inside of interstellar space, just how much harsher the environment is beyond it. The bubble our star blows is not only the boundary of its kingdom, it is a shelter, and Voyager showed us the edge of that shelter and what waits on the other side. And there is a reason scientists grew confident enough to use a word as strong as confirmed. Voyager 1 was not alone out there. 6 years after it crossed the boundary, its twin, Voyager 2, crossed the Salmon, shore in a completely different direction. And it too found the interstellar medium denser than the models predicted, corroborating from a separate location what its sibling had reported. When two machines, launched together, sent to different corners of the frontier, come back with the same surprising answer, a single strange reading becomes a genuine result. The higher density was not a fluke of one spacecraft or one instrument. It was a real feature of the space beyond the sun's bubble, seen twice in two places by two independent witnesses. That is the kind of agreement that turns an anomaly into a discovery, and it is why the finding could survive the scrutiny that the word confirmed demands. This is what NASA confirmed, and it is worth being precise about what that word impossible actually means here, because it is easy to let it run wild. Voyager 1 did not find aliens. It did not pick up a message. It did not detect some cosmic object that breaks the laws of physics. What it found was subtler and, in a way, more unsettling. It found that the space we told ourselves was empty and silent is neither, that it hums with the faint, persistent tone, that it is denser than our best models allowed, and that it grows denser still as you travel outward for reasons no one has fully explained. The impossible thing is not a monster in the dark. The impossible thing is that, confident description of the most ordinary seeming place imaginable, the empty gap between the stars, turned out to be wrong. and it took a dying machine on the far edge of everything to prove it. But to keep proving it, to keep sending that steady stream of readings home, Voyager 1 has to survive. And that is a battle it is slowly, inevitably losing. To see how close we have already come to losing it, you only have to go back to late 2023, when the spacecraft nearly fell silent. NT for good. For weeks, it kept doing what it had always done, pointing its antenna toward the distant Earth and transmitting on schedule. The signal arrived, faint but present, caught by the enormous dish antennas that listen for it. But when engineers examined what the signal contained, they found it was meaningless, a repeating pattern of nonsense where there should have been neat, structured data. The machine was alive. It was still talking. But it had lost the ability to say anything at all, as if it were speaking in a language that had suddenly turned to gibberish. For a spacecraft 15 billion miles away, that is close to a death sentence. You cannot send anyone to inspect it. You cannot open it up. Everything you learn about what has gone wrong, you must infer from the broken signal itself, and every instruction you send takes almost a full day to arrive, with another full day before you learn whether it did anything. A single attempt at a repair costs the better part of 2 days of wading across a gulf so vast the numbers stop meaning anything. The small team responsible for the spacecraft, engineers who had inherited a machine older than many of them, set about a slow and painstaking diagnosis. Over months, working through that punishing delay, they traced the fault to the spacecraft's onboard computer, to a small piece of memory that had failed, most likely worn out at last after decades in the harsh radiation of space. The broken section could not be repaired from Earth and could not be replaced, but it might, perhaps, be worked around. The engineers carefully rewrote the affected code, broke it into pieces small enough to tuck into other still funky. Ioning corners of the machine's limited memory, sent the new arrangement across the 15 billion mile gap, and waited the long wait to see if the patient would answer. It worked. In the spring of 2024, after months of meaningless silence, Voyager 1 began once again to send clean, readable data. The engineering information came first, confirming the spacecraft was healthy, and then, one by one, the science instruments were brought back online and the faint hum of interstellar space was once again aflow. Hoeing home. A machine built in the 1970s, running on a sliver of power, farther from Earth than anything humanity has ever placed, had been diagnosed and repaired across a distance so great that light itself needs the better part of a day to cross it. It stands among the most remarkable feats of long-distance engineering ever accomplished, and most people never heard a word about it. But the rescue, extraordinary as it was, could not change the one problem no cleverness can solve. Voyager 1 is running out of power. There's a human dimension to that rescue worth dwelling on, because it says something about how thin the thread has become. The people who now care for Voyager 1 are, for the most part, not the people who built it. The original engineers, the ones who designed its systems and wrote its first instructions and watched it lift off in 1977, have largely retired or passed away. The machine has ubiquitously blasted them. The team that tends it today is small, a handful of specialists who have had to learn the logic of a computer designed before almost any of the tools they grew up with existed. Reading manuals typed on paper decades ago, keeping alive an understanding of a system that will never be built again. When something goes wrong, 15 or billion miles away, they are the only people on Earth who know how to answer it. And when they are gone, that knowledge goes with them unless it is carefully handed down. The spacecraft is now kept alive by a kind of inheritance, the care of a distant dying probe passed from one generation of engineers to the next, none of them willing to let it fall silent a moment before it must. The spacecraft carries no solar panels. Out where it is, the sun is just another bright star, far too distant and faint to power anything. Instead, Voyager makes its electricity from heat, from the slow radioactive decay of a supply of plutonium it has carried since launch. That decay produces warmth, and the warmth is converted into a trickle of current. It is an elegant, dependable system, but it has one fatal weakness. The plutonium is decaying, which means every year there's a little less of it, and every year the trickle of power grows weaker. The spacecraft produces meaningfully less electricity now than it did at launch, and the decline never stops and never reverses. It is a clock that only runs one direction, counting down toward the moment when there will not be enough power left to run anything at all. For years, the engineers have managed that decline the only way they can, by turning things off. Heaters have been switched off, and to the team's surprise, some instruments kept working even in the deeper cold, hardier than anyone expected. Non-essential. Systems have been powered down, and more recently, the hardest choices have begun, the shutting off of actual science instruments, not because they have failed, but simply because there is no longer enough power to keep them running. Each instrument that goes dark is a sense the spacecraft loses forever, a way of perceiving the universe that can never be switched back on. The team chooses carefully, weighing which measurements matter most. keeping the most valuable senses alive as long as possible, buying a little more time from a budget that only ever shrinks. And the projections pointed T toward the 2030s as the decade in which the last of the power fades, when the final instrument must be switched off and the spacecraft can send back no more science. E at all. For a while after that, it may still transmit a faint carrier tone, a simple signal carrying no information, just enough to say it is still there. And then even that will stop, not because the machine has broken, but because there will simply be nothing left to power it. It is worth pausing on how far away all of this is happening, because the distance is so extreme the human mind refuses to hold it. Voyager 1 is now so far from Earth that a radio signal moving at the speed of light, the fastest anything is permitted to move, needs more than 22 hours, simply to Hikechit. Send a command in the morning, and it does not arrive until nearly the next day. Wait for a reply, and it does not reach you until the day after that. Nearly 2 full days for a single round of conversation with a machine that is, in every sense that matters, one of us, a piece of human civilization still faithfully doing its job. And to hear it at all takes extraordinary effort. By the time the spacecraft's signal has crossed that gulf, it has spread and weakened almost beyond belief. Arriving so faint, it carries less than a billionth of a watt of power. To capture something that weak, humanity built enormous dish antennas, some of them 70 meters, across, spread around the planet so at least one always faces the right patch of sky. Great steel bowls that swing to track a machine they cannot see and strain to pull its whisper up out of the noise of the universe itself. That we can hear it at all is its own quiet miracle. Repeated every day, it still speaks. And even at the speed of light, even after nearly half a century of travel at roughly 38,000 miles an hour, fast enough to cross the distance from the Earth to the Moon in a matter of hours, Voyager 1 has barely begun to leave. On the scale of the galaxy, T has taken only the first few steps out the front door. The nearest star, in a direction the spacecraft is not even traveling, lies so far ahead that Voyager would need tens of thousands of years just to cover an equivalent T distance. Its journey has already lasted longer than most human lifetimes, and against the true scale of the space it is crossing, it has essentially not moved at all. And still, it carries something. Bolted to its side is a golden record, a disc engraved with sounds and images from Earth, a greeting assembled with almost heartbreaking. Me in particular, music from many cultures, the sound of rain, of a heartbeat, of a human kiss, greetings spoken in dozens of languages. It was never expected to be found. The odds of any other intelligence encountering it, in the emptiness it is crossing, are so small that it works less as a message and more as a gesture, a statement about who we were at the moment we made it, cast into the dark, not because we expected an answer, but because it felt important to try. Long after the spacecraft goes silent, long after everyone who built it is gone, that record will still be out there, still riding on the side of the quiet machine, still carrying the memory of a warm blue world that once looked up and decided to reach outward. That is the weight of what is at stake as the power fades. When Voyager 1 finally goes quiet, we do not just lose a spacecraft. We lose our only working instrument in a place we cannot otherwise reach. Everything it has taught us about interstellar space, the hum, the higher than expected density, the strange increase of that density with distance, the magnetic field that refused to rotate, all of it came from this one machine holding up a sensor where nothing else can go. Once it stops, that direct window closes. Its twin, Voyager 2, which crossed the same bound, Derry in a different direction 6 years later, is fighting the same losing battle against the same fading power and will not last much longer either. When both fall silent, we will have no direct measurements from interstellar space at all, and we will not have any again. And for a very long time, because nothing is flying now and nothing is far enough along in planning to take their place. A mission launched today would need decades simply to reach the boundary these two crossed years ago. There will be a gap, a silence, possibly generations long, in which humanity has thrown machines toward the stars but has no ears actually out there, listening, which makes the readings still arriving all the more precious. Every day Voyager 1 keeps transmitting. It sends back measurements from a frontier we did not fully understand, filling in a picture that is still incomplete, still surprising, still occasionally at odds with the models we trusted. The hum continues, stretched thin across 15 billion miles, delayed by the better part of a day, arriving faint and steady at the great antennas that strain to hear it. And it goes on describing a region of space that is stranger, denser, and more alive with structure than the empty nothing we once imagined lay between the stars. The machine reporting all this was built by people who mostly did not live to hear it. Using technology we would now consider almost laughably primitive, running on a whisper of power, alone in the true dark, doing science no one else can do, right up until the moment it cannot. There is something almost humbling in how ordinary the discovery sounds when you strip away the drama. No explosion, no collision, no alien structure looming in the dark. Just a faint tone, a density a little higher than expected, a magnetic field pointing the wrong way, a bombardment of particles beyond a boundary. These are quiet findings, the kind that never make a dramatic photograph. And yet they matter enormously because they concern the most basic question you can ask about the space around our solar system. What is it actually like out there? And because for the entire history of science before Voyager, every answer to that question was a guess made from a distance. We had never stood in interstellar space and measured it. Now, through one machine, we finally have, and almost every reading it sends back tell. SUS, our guesses were incomplete. That is the real lesson buried in the word impossible. It is not that the universe broke a law. It is that we were confidently wrong about a place we had never actually visited, and it took a dying spacecraft, listening to a sound it was never built to hear, to show us how wrong. So when you hear that NASA has confirmed Voyager 1 found something impossible, understand what that actually means. It means that our confident picture of the space between the stars was wrong, that a region we insisted was silent and empty turned out to hum with a faint, persistent tone, to be denser than our models allowed, to grow denser still with distance, and to carry a magnetic field that behaved in ways we did not predict. And it means that a nearly 50-year-old machine, by the simple act of surviving long enough to get there and listen, caught our understanding falling short of this. Truth. The impossible thing is not some hidden signal or cosmic monster. The impossible thing is that a spacecraft this old, this small, this far away is still teaching us, still correcting us, still reporting from a place we told ourselves we already understood and clearly did not. And somewhere in the 2030s, that will end. The last instrument will reach the threshold below which it cannot run. The final packet of real data will be assembled by that aging computer, transmitted by that fading transmitter, and begin its long journey home, crossing more than 15 billion miles of darkness over the better part of a day, to be received and recorded on the world that built it. And after that packet, there will be nothing. No more corrections, no more surprises, no more hum from the deep. Voyager 1 will keep moving, silent now, at 38,000 miles an hour, carrying its golden record through a night so vast that the next star, along its path, lies tens of thousands of years away, and the faint tone it spent its final years describing will go on singing in the dark, unheard now, with no one left out there to listen. One machine, a few watts of power, 15 billion miles from home, still reaching us. Still, for just a little while longer, telling us things we did not know and were not ready to believe.